On targets 1 and 2 that we have here, we're actually going to switch gears a little bit, and we've been talking a lot about equations in class, but we're going to talk about inequalities. So real quick, the difference between an equation and an inequality is, first of all, for an inequality, you'll notice that we're using greater than and less than symbols instead of an equal sign, but also with an inequality, we have the option for many more solutions. Instead of just x equals 2, it could perhaps be everything greater than 2. So to start off with, we're going to look at this algebraically, and we're going to determine if the given number, so on A, 5, makes the statement true, it's a solution or not. So I'm just going to plug this in for x. Is 5 greater than negative 3? It sure is. So this is a solution. If that was false, we would just say not a solution. So same thing here on B. Take this negative 7, plug it in. It's negative 7 less than or equal to negative 7. Because it has that equal to component, that makes it a true statement. If it was just is negative 7 less than negative 7, that would not be true. And again, same idea here on C. Plugging it in, we have a little bit more of some calculations to do here. And you actually really don't have to go further than this. If you just think about what's 3 times 9 plus 5, that's going to be more than 23, because if we have 3 times 9, that's 27 right off the bat, and we're adding 5 to that, so not a solution. So just getting used to that idea of an inequality greater than or less than. Now we're going to graph some inequalities, very basic. So whenever we graph on a number line, make sure that you label at least 3 tick marks. So I'm going to definitely use negative 3, since that's the number in the inequality. And then I'm going to put negative 2 here and negative 4 here. So I've labeled 3 of the tick marks just to get an idea of where we are on the number line. I skipped a tick mark in between just because the smartboard marker is kind of thick and that would be too scrunched. So at negative 3, notice that the inequality says it can't equal negative 3. So since it's not equal, we're going to make an open point. And it says x is greater than negative 3. So the numbers that are greater than negative 3 would be going to the right. So again, on B, we still have that number of negative 3. So I'm going to label my number line in a very similar way. But this time it says x is less than or equal to negative 3. So since this time negative 3 is included because it could be equal to, I'm going to make a closed point. And then I'm going to shade towards the left because it says numbers less than negative 3. When we get into the bottom of target 7, this is really what the bulk of the material will be. So what we're going to do is solve the inequality, and then we're going to graph. So we're going to use a little bit of everything that we've been doing previously on these notes. So when we solve the inequality, it's very similar to solving an equation. So we're trying to get the variable by itself. So I'm going to add 4 to both sides. So x is greater than 1. So since the variable is by itself, we have solved this inequality. And then just like I did above, I'm going to make sure that 1 is somewhere on my number line. I'm going to do a number greater than and a number less than. At 1, I'm going to make an open point since it's not equal to, and it says x is greater than, so I'm going to shade to the right. On B, there's a little bit more solving involved, but it's the same idea. So I'm going to get all the variables on one side, so I'm going to subtract 7x. So I have negative 2x minus 4 less than or equal to negative 10. Add 4. So now I have negative 2x is less than or equal to negative 6. When I divide by a negative, so I'm dividing by a negative 2 here, this is where solving an inequality is a little bit different than an equation. When you divide or multiply by a negative, you have to flip your inequality symbol. So I'm going to flip the way that it's facing when I divide by that negative. So we have x is greater than or equal to 3. I'm going to put 3 on the number line, number greater than, number less than. 3 is included this time, it is equal to, and it says x is greater than, so I'm going to shade to the right. C takes us back to using order of operations. We do parentheses and multiplication first, so I'm going to go ahead and distribute the 5. And then again, we're just going to get the variables on one side. And I'm going to get my constants on the other side. Dividing by 2, I don't have to, I don't have to flip the symbol this time since I'm dividing by a positive 2. And we get x is less than 9. So I'm going to put 9 on the number line, a number number greater than, a number less than. 9 is not included, and we're going to the left because it's less than. The final example for target 7, you guys are getting the hang of it. So I'm going to add that x over, so we have 2 x's. Then I'm going to add the 2 over. We don't have to worry about flipping the sign on this one either because we divide by a positive 2. So notice that 7 divided by 2, it doesn't come out evenly. I'm going to write it as a decimal because when it comes to the number line, I could put 3.5 here and then I could put 4 and 3. So it's just any number less than and greater than. And it doesn't have to be, like, you don't have to plot 3.5 in between two tick marks. You can make it its own tick mark. And so 3.5 is included and it says greater than, so we're going to shade to the right. All right, on the other side of your notes, target 8. So now we're going to graph a linear inequality, and we're not graphing on a number line anymore. We're actually graphing on a coordinate grid. So I'm going to show you a couple different methods to do this. Starting off just by going back to what we remember about slope-intercept form. So these inequalities are actually in slope-intercept form. So by looking at the inequality, you can determine what is the slope and what's the y-intercept, and that will help us graph. So looking at A, by identifying the slope, which is -1, and the y-intercept, which is 2, we can graph this line portion of the inequality. So I'm going to start my graph at 2 on the y-axis. There's a slope of -1, so make sure it's going downhill. I'm going to spread these points out a little bit just because it was getting a little bit jam-packed there. And before I connect these points, notice that our inequality symbol on this problem is not equal to. Whenever it's not equal to, we're going to use a dotted line. So when I connect these points, I'm not using a solid line, it's a dotted line. Now from here we have to do some shading. So either all of our solutions lie above this line or they lie below this line. I'm going to give you two different methods to think about this. The first method is the test point method. You pick a point on your coordinate grid, 0, 0 is usually a pretty easy one, and you plug it into your inequality. So remember our inequality is y is less than -x plus 2. Plug in your x and y coordinates, which for me they're both 0. I wrote -0, but that's just 0. And you see if it's a true statement. Is 0 less than 2? Yeah, it is. That's a true statement. So that means wherever 0, 0 is, which is right here, we're going to shade that side. So essentially I'm shading under my line. So that's one way to graph a linear inequality. However, you could also come up with your shading by just looking at your inequality symbol. So remember it says y is less than. So because it's less than, we can actually just shade under the graph. And I'll talk about that again on this next one. So in our next example, our slope is -3/4. Our y-intercept is 4. So we've been practicing graphing, so hopefully this is coming pretty easily to you. I'm just using the slope and the y-intercept to create the graph. The other thing I'm thinking about as I'm plotting these points is whether I'm going to have a solid or a dotted line. So looking at this inequality symbol, because it's equal to, it's going to be a solid line. That's a really common mistake that we see on assessments, is just forgetting to check to see if it's going to be solid or dotted. Now on this one, it says y is greater than or equal to the expression. So since it says y is greater than, that means we're going to shade above. That was that second method I showed you on the last problem. But remember, you can always use the test point method. So again, just 0, 0 is a really easy one to use. You have your x and your y, and you can plug it into your original inequality, which I'm just copying down here. So plugging in 0 for each of those variables. And so we get 0 is less than or 0 is greater than or equal to 4, which is not true. So notice 0, 0 would be right there, and we did not shade that side because it was a false statement, so you would shade the opposite side. And you could also use a test point and just the knowledge that when it's a greater than, you shade above, and less than, you shade below. You could use that to kind of check your work. So if you're really comfortable with using a test point, there are situations that you actually can't use a test point. So let's take a look at this graph. So notice that this is also in slope-intercept form. The slope is 3, the y-intercept is 0. So we're going to start at 0, go up 3/1. It's a super steep line here. Be thinking about if you have a solid or a dotted line. It would be dotted. Okay, so in this case, notice that 0, 0 is actually on the line. So when 0, 0 is on the line, you can't use it as a test point. You can't use any test point that's actually on the line. So you have a couple options here. You can either say, well, it says y is less than 3x, so I'm going to shade below, or anytime that you want to use a test point, you can pick any point at all on the coordinate grid. So I could use 10, 0. 10 is x, 0 is y. And then plugging that in, I have 0, that would be is less than or equal to, or not less than or equal to, just less than 30. And is that a true statement? Is 0 less than 30? It is. And so 10, 0 is over here, so I would shade this side of the graph. So just pointing out, you can't always use the test point of 0, 0, but you can always use a test point. You do not have to use a test point by any means. That's just a strategy.